Okay, this video covers the 2019 AP Calculus official practice exam. We're just going to do number 4 in this video. And you're going to want to have the sheet out. It refers to this graph. So if you read through the problem, it says that g of x is equal to -4 to x of f of t dt. And remember, from the fundamental theorem of calculus, if we plug x into t, so you can take the derivative, g prime of x is just going to be f of x. Okay, so this graph, this is a graph of f. It's also a graph of g prime. Okay, so we're going to be able to answer a lot of questions about g, assuming this is the graph of g prime. So just mark that on your paper, also graph of g prime. It's really a decent chance that you will get a question like this on the 2020 test. So part A says find g of 0 and g of 4. G of 0 is pretty easy. G of 4, there's quite a bit of work to that. So first of all, the way that you do it is you go from -4 and you plug 0 into x up here. So -4 to 0. Now, if it had turned out that these were reversed and it was 0 to -4, we would have to flip those by putting a negative out front. Okay, we'd have to put a negative out front, but we don't have to on this one. So, of f of x dx. So, what we need to do is find area under the curve from -4 to 0. That'll give us g of 0. So what you can see here is from -4 to -1, it's just a triangle, and it's above the x-axis, so it's going to be positive. And then we'll have to add to that the area of this parabola, and that one is given to you in the problem. That area is 3, but since it's below the x-axis, the area of A we will have to subtract. Okay, so from -4 to -1, we have a triangle. The area is 1/2. The base is from -4 to -1, so 3. And then the height, you can just read the graph and see that's 3. So that's 9/2. And then from -1 to 0, the area is 3, but since it's below the x-axis, right, we would have to subtract 3. Okay, so g of 0 then is going to be 9/2 minus 3. Okay, so minus 3 would be 6/2, right? Okay, so that minus 3, I just changed that to halves. And that would be 3/2. All right, we'll need to use that in the future. But g of 0, not too bad. And they made it easy on us by putting the lower limit first, so we didn't have to flip those. G of 4, mathematically, is more work. It's not really any harder. So g of 4 is going to be -4 to 4 of f of x dx. So we just place that 4 right into the top here. So we need to get the area under the curve from -4 to 4, but we already have half of that. So that's going to be from -4 to 0 of f of x dx plus 0 to 4 f of x dx. And this we already know is 3/2. So we'll just come back and insert that later. We just got to figure out 0 to 4. All right, so taking a look at this, 0 to 4, we know the area for B, and it's positive. It's 5. So 0 to 1, it's 5 from the problem. So we got to figure out from 1 to 4. And they gave us the equation for that in the problem. It's going to be from 1 to 4 of negative x squared plus 5x minus 4. Okay, we can do that by hand. So that's going to be negative 1/3 x cubed plus 5/2 x squared minus 4x, and we've got to evaluate that from 1 to 4. So that's going to be negative 1/3 times 4 cubed plus 5/2 times 4 squared minus 4 times 4 minus, and then we're going to plug a 1 in for all that. So negative 1/3 plus 5/2 minus 4. Now you get to have a calculator on this, so you're not going to have to spend a ton of time like they would have in prior years with no calculator trying to figure out what that is. But if you go through if you put all that in your calculator, you're going to see that it's going to end up being that amount is 8/3 plus 11/6. Okay, so that is going to be, let's see, 24 plus 11, so 25/6. All right, I'm sorry, 16 plus 11. 27/6. Let's see, yeah, that's right. So that's just from 1 to 4. Okay, so your final answer is going to be 3/2 plus, so this amount here, plus from 0 to 1 is 5, plus from 1 to 4 is 27/6, and that's 11. So very helpful to have your calculator on the second part. Now, the first part, g of 0, is easy. You could have gotten that pretty quick. You might, on the 2020 test, want to skip g of 4, go on to the next part, and leave space to come back and finish that. So you're going to want to have your your pages numbered and your APID on those pages and your initials, and have them all ready to go so that you can come back and have space to work the second part. But since that took a while, I would probably skip that one. Okay, and that's part A. Let's parts B and C are pretty short, so it was the second part of part A that took most of the work. All right, let's look at part B. So part B, part B, so we're using this graph. The question on part B says find the absolute minimum value of G on the closed interval -4 to 4. Okay, so we want the minimum from -4 to 4. So when you have a closed interval, you must look at the endpoints and where it goes from negative to positive. Okay, that's a critical point that could be a minimum. So we're going to look at the endpoints. We're going to look at -4. We're going to look at 4. And then we know it goes from negative to positive, the graph, because that tells you where there's a minimum at 0. So we're going to look at G of -4. That's a possibility. G of 0 and G of 4. Luckily, we already have two of these. We figured out G of 0 is 3/2 and G of 4 is 11. So we got to figure out what is G of negative 4? Well, that's going to be from negative 4 to 4, excuse me, negative 4 to negative 4, because this function is defined from negative 4, so we're going to put negative 4 in for x of f of x dx. Well, what's area from a point to a point? That area is 0. Okay, so our minimum is 0. All right, and that occurs at x equals negative 4. Okay, so you had already done all that work, and it looks like, you know, maybe I misspoke on the previous one. You're going to have to do all the work on g of 4 on the previous problem in order to know that's 11 in order to answer part B. So, yeah, you probably would have had to go back and work that out. But once you work that out, part B is super short. Okay, let's take a look at part C. I think I can fit this on this paper. So part C says, again, we're referring to this graph here. Part C says, find the intervals in which G is concave down. Give a reason. Okay, so our reason is that G is concave down. You'd have to write this out, where the slope of G, so the slope of the derivative, and you need to have that sheet ready to go that tells you how to read the graph of a derivative, where the slope of G prime is negative. So that's your explanation. We're looking, where is the slope negative? Well, the slope is negative, first of all, from negative 2 to negative 1/2. And then it's negative from 1/2 to 1, and then from 2.5 to 4. Okay, that's where the slope is negative. So you can write them, you could write them like this. Now they have to be open intervals because at those critical points, it's neither concave up or concave down. So negative 2 to negative 1/2, from 1/2 to 1, and then the third place the slope is negative is 2.5, so that'd be 5/2 to 4. Okay, so you got to have the explanation, then put the intervals, and boom, you're done. So B and C is really quick. Most of the work came from the second part of part A. So that's going to be it for this video. I will talk to you on the next video.